Right, so in this lesson, we're going to be talking a lot about deductive reasoning. So what was the kind of reasoning we talked about in the first section where it was like looking at patterns and trying to determine what the next things could be, trying to extrapolate from the certain amount of information. That was inductive. This is deductive, okay? Deductive reasoning is actually what you're used to thinking of as math. Okay, deductive reasoning is following rules or properties, definitions, facts to go from like one step to the next, like logically going step by step. Okay, so inductive reasoning was what we did before. Inductive reasoning was from before, and then deductive is what we're going to talk about in this whole lesson. Okay, the definition for deductive: using facts, rules, definitions of properties to reach logical conclusions from given statements. With deductive reasoning, it's never open to interpretation, okay? It's always going to be, you follow these rules, everyone ends up at the same place. You know how with like inductive, sometimes like that one where it was like sales on the review, you're predicting like what the sales will be, and somebody looks at it and says, oh, you're tripling, and somebody else looks at it and says, I found this other rule. With deductive reasoning, that won't happen. Okay, so here are some examples just determining inductive versus deductive. For the last 2 Fridays, the cafeteria has served pizza. Julian concludes that the cafeteria will serve pizza every Friday. So the question is that a policy, rule, procedure, or is that an observation that is leading to a conclusion? Is that inductive or is that deductive? Switch colors here. Nick, what do you think? Tell me why. Yeah, so I forget his name. Julian is saying, well, this is what I noticed, and so this is the pattern I see, and this is what I think is going to happen. Okay, if it was deductive, it would say the menu, not calendar, the menu for the cafeteria is that every Friday they will serve pizza. Like if that was a kind of like a policy, then it would be deductive. Jake's utility company charges him a late fee of $7 if his payment is not received by the due date. Jake paid his utility bill late this month, so he concludes that he will owe a late fee of $7. Nicholas? Because? Oh, you're Philip. I'm sorry. I had Nick in my head. Okay, that's a policy, right? It's like if this happens, then that's going to happen. So for deductive, if it's again like a rule, policy, procedure, then you know what's going to happen. No student whose parents dropped them off at school owns a car. Okay, I know that might not be true. Just assume that that's true for sake of this argument. Courtney's dad takes her to school every day. Therefore, Alex can conclude that Courtney doesn't own a car. No student whose parents drop them off at school owns a car. Courtney's dad takes her to school every day. Therefore, Alex can conclude that Courtney doesn't own a car. Jake, what do you think? Why? Okay, so that is something that we are assuming to be true. So Courtney's dad taking her to school and Alex assuming that is kind of following the procedure. Jack, what do you think? Say what? Okay, this is something that's actually like we know is happening. Okay, Courtney's dad takes her to school every day is something that actually does really happen. So as far as like not that not being true, like this is something that we know is true. Okay. The fact that Alex is concluding that is because he knows that this is like a true statement. Okay. And since Courtney's dad takes her to school every day, then Alex says, well, therefore that situation applies to Courtney, and therefore since her parent drops her off, that means she doesn't own a car. Okay, so I agree that is deductive. Okay, in August and September, Jules received an email from his bank on the 1st of the month. Thus, he concludes that he'll receive an email from his bank on October 1st. Inductive or deductive? Which one? Tell me why. Yeah, he's taking what's happened and trying to predict what's going to happen in the future. Okay, so again, inductive is making observations that lead you to conclusions. You're trying to take a few situations and extrapolate to a broader conclusion. All right, counterexamples. Just a reminder here, remember that when you are trying to disprove a statement, which is a conjecture, then one counterexample will do it. But if you're trying to prove a conjecture is true, you're using deductive reasoning. So if you're trying to prove something is true, you start with a given and you apply rules, policies, procedures, definitions in math, theorem, and postulates, and like develop an argument. Okay, first kind of deductive reasoning that we're gonna like kind of look for the pattern here. If P implies Q, that means that you have two statements that are put into if-then form, okay? You have an if-then, this is called law of syllogism. It's a soft G. It's not syllogism, it's syllogism. If P implies Q and Q implies R are true conditional statements, okay, then P implies R is also true. So these are both if-then statements, right? What do you notice about the letters? What do you notice about the group there and the group there? I know it's a really general question. Why is it going to be P implies R? What happened to Q? What happened to Q?
Implied by Q and implied by.
Okay, so because Q is the ending of that sentence, the conclusion of this sentence, and the hypothesis or the beginning of the second sentence, it's kind of like wiped out. So that's saying the law of syllogism says that if you can match the ending of one if-then statement with the beginning of the next one in that order, then you can remove that commonality and go straight from the first thing to the third thing. If thing one implies thing two and thing two implies thing three, then thing one implies thing three. That is similar to a rule in algebra. Do you remember what that is? Syllogism is similar to, we're going to do properties of algebra next lesson, I think. That is a property. Do we know what that is? You'll know what it is after the next lesson. That's transitive. Anybody recall what transitive is like? Does that sound familiar to you at all? Like, no, not really. Some of you that are in Algebra 2 probably have already reviewed those properties. Transitive property of equality. Okay, it's kind of like a transitive type of idea. Transitive property of equality says if A equals B and B equals C, then your conclusion would be what? Alexis? Then A equals C. So same idea, you're just taking out that common, you know, if two things are equal and then the second thing is equal to the third, then they're all equal basically. Okay, so this is how syllogism looks. If I pack my practice clothes at night, then I won't have to do it before school. If I don't have to pack my practice clothes before school, then I'll have time to eat breakfast. So see how we have two if-then statements here? I want you to think of that like statement number one. Think of this as statement number two, and our conclusion is going to be what we can get from that, okay? So if I pack my practice clothes at night, then I won't have to do it before school. Notice that this is matching with If I don't have to pack my practice clothes before school, then this other thing follows. So because the ending of the first sentence is matching the beginning of the second sentence, then you can kind of get rid of that and group these guys together. So what would our conclusion be? What would our conclusion be? Dayanara. I'll have time to eat breakfast. Okay, this is called syllogism. If I pack my practice clothes at night, then I won't have to do it before school. If I don't have to pack my practice clothes before school, then I'll have time to eat breakfast. So therefore, if I pack my practice clothes at night, then I'll have time to eat breakfast. Okay, so that's your conclusion there is like your third statement. All right, so syllogism is like transitive. Two if-thens that get mushed together into a conclusion that is the hypothesis of the first sentence and the conclusion of the second sentence. And they have to go in order, because remember that even if a P implies Q statement is true, the converse of that does not have to be true. Okay, so you want to make sure that they're in order like that. Okay, the second one is called law of detachment. Law of detachment. This time you only have one if-then statement. Okay, so P implies Q is given to be a true statement. The second part is going to be a specific example of the hypothesis. And you'll see what that means in a minute. Then that means that that statement also applies to the conclusion. So this is kind of, this one looks a little bit weird in terms of notation, but the idea is not hard. So here are two statements we're going to assume are true. So when we're doing these problems, we're, you know, sometimes when I try to use like real life examples, it's a little bit like shaky as to whether it's true or not, but I'm going to assume that these are true statements. Okay. If a student earns high grades, then he or she will make honor roll. There's your if-then statement. Your second statement is Lisa earns high grades. So see how this is a specific example of a person who earns high grades. It's a specific example of the hypothesis. Okay, it says then Q is true. Okay, so if any student earns high grades, then he or she will make honor roll. Lisa earns high grades. What can you conclude? Jake? Okay, it will not be an if-then statement. See the conclusion here? It's not going to be an if and only if, and it's not going to be an if-then statement. It's just going to be like a normal statement like the way that this one was, like number 2. Okay, so number 2 says Lisa earns high grades, so your conclusion is going to be Lisa will make honor roll. Now, you do not have to write, you should not write this one in if-then form. Okay, we're assuming, I'm writing up here, listen. We are assuming that that if-then statement is true. So if we talk about anybody who earns high grades, the conclusion is that anybody should be making honor roll. Okay, this is called law of detachment. You can kind of think of this like you've plucked off an example of the hypothesis. You've detached, like you're cutting off this from the end of the sentence. So like, here's a true statement. If this happens, then this happens. Then it's like, well, this did happen. Therefore, that general sentence applies to that specific example as well. But you have to make sure that this applies to the first part of the if-then statement, to the hypothesis. Okay, write a conclusion using the true statements, state which law applies. If no conclusion is possible, write no conclusion. Okay, so let's kind of write a little help up here, little helper. Syllogism is the one that goes, if P implies Q and Q implies R, then P implies R. Detachment will be I'll just go. P implies Q. Specific example of P. And then that, I don't know how to say this, Q is true. That if then, sorry, I know it's got really messy all of a sudden. Specific example. That if then applies to the example. All right, so let's look at a few examples here. If a person gets a concussion, then he or she should see a doctor. So I want you to think of these like 3 sentences. I think that's the easiest way to sort of work your way through this, okay? Sentence 1, if a person gets a concussion, then he or she should see a doctor. Sentence 2, Jamie got a concussion. What do you think the conclusion would be, and which law is it? Sammy?
Jamie should see a doctor.
Good. Jamie should see a doctor. Tell me why it's detachment.
It has a conditional.
Yes, good. So this, Jamie got a concussion here, is a specific example of a person who got a concussion. Okay, I assume that Jamie is a person and not a dog, fish or something. Can fish get concussions? I don't know. And if they did, would anyone know? Probably not. Why is your fish like swimming all weird? They have a concussion. Do fish have any bones? Yeah, they have bones. I wonder if goldfish have a lot of bones. Random thoughts on a Friday. Okay, let's look at the one over here. If you chew gum, then you will get a detention. If you get a detention, then you will have to serve it. So this is sentence 1. If you chew gum, you'll get a detention. Sentence 2. If you get a detention, you'll have to serve it, meaning the detention. Okay. What's the conclusion and which law is it? I want to talk to somebody who hasn't talked to me today. Yeah. If you chew gum, then you will have to serve a detention. Notice she didn't say then you will have to serve it, because that wouldn't really make sense. Sometimes when you take out that beginning or that like middle chunk there, you might have to reword it a tad so that it actually makes sense. If you chew gum, then you'll serve, I'm just going to abbreviate this a tiny bit there. So you said it's which law? Did you tell me? Syllogism, good. So the ending of the first sentence matches up with the beginning of the second sentence. You can take it out and mush them together. Okay, it's like those little trains. Did any of you have those little wooden trains when you were like a little kid that has the magnets on them and you like link them end to end? Yeah, Hank knows what I'm talking about. So it's like, you know, it has to go in the right order for them to be able to link together. So you're attaching the end of one of them to the beginning of the next one. Okay, if Jay doesn't work hard, then he won't start the game and he'll quit the team. Jay quit the team. So here's sentence 1, here's sentence 2. Okay, so again, write a conclusion using the true statement, state which law it is. If no conclusion is possible, write no conclusion. What do you think? Okay. Okay, so which law do you think it is? Okay, so let's check law of detachment. If J doesn't work hard, then he won't start the game and he'll quit the team. Remember that for detachment, the second sentence needs to be a specific example of the hypothesis. So is this a specific example of the hypothesis? Meaning, here, let me make this a little bit more general. How about if a player, let me do this. If a player doesn't work hard, then he won't start the game and will quit the team. J quit the team. Is that a specific example of somebody who is a player who didn't work hard? Okay, so that means this cannot be detachment. These ones are a little bit tricky because the pattern looks like detachment, but it's not actually detachment. Tell me why we can't say that J didn't work hard. Okay. Right, there's other possibilities, right? So it's like if J doesn't work hard, he won't start the game and he'll quit the team. Well, we don't know if J worked hard or didn't work hard. What are other reasons that somebody might quit a team? Emma? Maybe he got hurt. What are other reasons? Jake? Didn't like the coach. Jack? He was bad. Is that what you said? He was a bad player. He was like, I'm just done. This is dumb. Okay. Anything else? I can think of at least 2 other reasons. Oh, you can't come up with Philip. He just doesn't want to play. Okay. Hank? Okay, he doesn't like the sport. He got in a fight. Elliot? What was that? One more time. You guys repeat for me. I can't hear. What?
The coronavirus.
The coronavirus. He had to quit because he was in quarantine. Okay, so like sometimes, you know, your grades aren't good. What happens? Your parents are like, you got to quit because your grades are terrible and you need to spend more time studying. Maybe he had to get a job. Like there's lots of reasons why Jay might have quit, right? So this one is going to be a no conclusion. And that's because we cannot go backwards. Remember that a conditional statement could be true. So it could be true that if Jay didn't work hard, then he won't start and he'll quit. However, we don't know that just because Jake quit, that it's because he didn't work hard. Okay, there's other possibilities. The converse is not necessarily true. Okay, and again, those are a little bit tricky. So the no conclusion ones basically mean it's not going to follow the correct pattern for syllogism or detachment. The other thing you can do is kind of think like, how would I make a valid argument? Let's say that statement 1, this would be a good argument. That's supposed to say okay. This would be a good argument. Let's say that sentence 1 was if J doesn't work hard, then won't start and quit. Okay, he won't start and he'll quit the team. What would sentence 2 have to be if this was going to be detachment? Sarah? Jay doesn't work hard or Jay didn't work hard. If that's actually true, if it really happened that he didn't work hard, then that conclusion is going to be what you say. Your conclusion would be Jay won't start and will quit. Okay, so again, the order, you got to make sure you're going in the forward direction. We're going to continue here with syllogism and detachment. So remember, there's kind of patterns to each of those that we're going to be using here. So these examples say, determine whether statement 3 follows from statements 1 and 2 by the law of detachment or the law of syllogism. And if it does, state which law, and if it does not, write invalid. So these are a little bit different than the ones up here because up here it said to write no conclusion because it gave you 2 statements and you either can or cannot make a conclusion. These are complete arguments. So the question is it a valid argument or is it an invalid argument? Okay. Josh? All right, so the first one here says, if the measure of angle 2 is 40 degrees, the measure of angle 3 is 140. And then the second one, if the measure of angle 3 is 140, then the measure of angle 4 is 40 degrees. Can you conclude, so you think of these like step 1, step 2, step 3. Can you conclude that if the measure of angle 2 equals 40, then the measure of angle 4 equals 40? And if so, which law is it? If not, it'll be invalid. I have not talked to, let's see, Nick Beerby. Valid or not valid? Okay, what's the law? Tell me why. Okay, so you're taking the ending of this one and getting rid of it, and the beginning of this one and getting rid of it, and then taking the 40 from the first one and the 40 from the last one to get your conclusion. That is not detachment. That's syllogism, right? If P implies Q is true, and if Q implies R is true, then P implies R is true. So that one is valid, but that is lost syllogism. Okay, well, let's look at this one. Statement 1, if an angle is acute, then it is not obtuse. Statement 2, angle ABC is acute. Conclusion, is it possible to conclude that angle ABC is not obtuse? So again, think of these like step 1, step 2, is step 3 a valid conclusion? Leah. Is, go ahead, it is detachment because okay, so statement 1 says if an angle is acute, then it is not obtuse. That's a true statement, right? If an angle is acute, it's not obtuse. This is a specific example of an angle that is acute. Okay, a specific example of the P, of the hypothesis. Therefore, that statement applies to angle ABC. If an angle is acute, it's not obtuse. Here's an acute angle, ABC. Therefore, angle ABC is not obtuse. Again, notice that this one is not an if-then form. It will be the conclusion, like that first sentence applied to that specific example. Okay, not an if-then form. Okay, right angles are congruent is statement 1. Statement 2 is angle A is congruent to angle B. And the conclusion that we are considering is it true that angle A and angle B are right angles? Is that a valid argument? So what might be helpful is if we write the first sentence in if-then form. So, almost everybody. Josh, what's that first sentence in if-then form? Okay, if two angles are right angles, then they are congruent. If it's not written in if-then form, I think it's helpful to do that first. Okay, if two angles are right angles, then they're congruent. And so that's replacing this. Okay, angle A and B are congruent. Can we conclude that angle A and B are right angles? Josh is saying no, because why? What do you mean by two different angles? Okay, do they have to be complementary? So as long as they're congruent, they don't have to be right angles, right? So why is this not detachment? Why is that not detachment? Because it kind of looks like the pattern for detachment. Why is that not detachment? Jake? Okay, so when you're looking for the pattern here, you need to be thinking about this as an example of that, but it's not. Okay, that is referring to the conclusion. It should not be referring to the conclusion because the converse of that statement is false, right? If two angles are congruent, they don't have to be right angles. So when you have a second sentence that's referring to the conclusion of the first sentence, even though that original statement is true, the converse of it is not. So if I give you an example of two congruent angles, they don't have to be right angles. They could be both 30 degrees. They could both be both 45 degrees or whatever, okay? They don't have to be right angles. So again, the reason that we're writing invalid on this one instead of saying no conclusion is because the conclusion's already there. It's just a false conclusion. It's a wrong conclusion. Okay, so these are complete arguments. They're just invalid arguments in that situation. So watch out for this one because this kind of looks like detachment. It's sort of like a fake detachment. So it kind of disguises itself like detachment because it's got that if then and then the statement and then the conclusion, and they're not an if then form, but it's not following the correct pattern. Okay, last example here. Well, not last, but almost last. If you drive 50 miles per hour in a school zone, then you will get a speeding ticket. That's statement number 1. Statement number 2, Pat received a speeding ticket. Statement number 3, is it possible to conclude, again, think of this like, is this a valid conclusion? Is it valid to conclude that Pat was driving 50 miles per hour in a school zone? Jack, explain. Okay, so there's other reasons that Pat could have gotten a speeding ticket, right? So why is that not law of detachment? Because again, it sort of looks like it should be. Why is that one not law of detachment? Pat is a specific example of somebody who did what? Philip, explain why is that not valid? Yeah. Okay, so Jack said he could have got a speeding ticket on the highway, is what you said. Okay, so if you drive 50 miles per hour in a school zone, then you'll get a speeding ticket. Pat received a speeding ticket does not mean that that's the reason why he received a speeding ticket. Again, if it's referring to the conclusion instead of the hypothesis, you're not going to be able, like if it's going to the end here rather than the beginning, you're not going to be able to make a valid conclusion from that. So it is possible Pat was driving 45 miles per hour in a school zone. It was possible he was speeding not even in a school zone. Okay, there's other ways that he could have gotten a speeding ticket. So again, the ones that look like fake detachment, tell me how, let's talk about this one actually. Tell me how we could rearrange those to make it a valid argument. You still have statements 1, 2, and 3. What would be the order that would actually put it in the correct valid argument? Yeah. Okay, so if you basically just flip-flopped which two? Statements 2 and 3, if you flip those around, and the conclusion was that Pat received a speeding ticket, then that would be a valid argument. So if we had, you could make this valid by switching 2 and 3. When I give you these sentences, you want to assume that it's in the order that you should be considering it. The last thing would be your conclusion, right? Make it valid by switching statement number 2 and statement number 3. So if it said, if you drive 50 miles per hour in a school zone, then you will get a speeding ticket. And then the next statement said, Pat was driving 50 miles per hour in a school zone. Here's somebody who was doing that. Your conclusion would be that that person got the speeding ticket, so Pat got a speeding ticket. Jake. It would be detachment. It would be a valid detachment. Yeah. So again, for detachment, you have to have an if then, and then that second sentence needs to refer to the hypothesis. So here's an example of an angle that's acute. Okay, but I didn't say that here. I need an example of somebody who was driving 50 miles per hour in a school zone. That's not Pat. Okay, take a minute and read that last example and see if you think that is syllogism or detachment. It looks like it's detachment, right? You have an if then, and then you have these two other statements that are not if then form. But like Nick said, the problem is if statement number 1 was if two adjacent angles form a straight angle, then the angles are supplementary. Statement 2 is saying here are two angles that are supplementary. But it's not supposed to be an example of the conclusion because again, if you read that first sentence backwards, the converse of that first sentence is false. So if we try to apply it backwards, that's going to lead us into trouble, okay? Our statement number 3 here is invalid because just because two angles are supplementary does not mean that they're necessarily going to be adjacent and forming a straight angle. Basically, this is referring to linear pairs and supplementary. Okay, so watch out for the ones where it's referring to the conclusion. All 3 of those, the invalid ones, look like they're law of detachment, but when you look at the second sentence, it's actually referring to the conclusion of the first sentence, and therefore it will not give you a valid conclusion for step 3.